Good afternoon, doctor. My name is Gan Kiyu from Group 9 of Fundamental of Image Processing, Session 2. And now I will present how to open the script. And first we need to open the command prompt. And first we press CD and copy the path of file. And we can open the code and we use the image S6 as an example. First, after restoration by using solution 1. And next, we'll try on the solution 2. And this is the solution 2 to produce the image after restoration. And this is the noise picture and the picture after restoration. And next, we will check out the similarity by using the solution 1. And we can see the percentage of similarity is 62.95% for the solution 1. And next, we go through the solution 2. And we can see that the similar percentage for similarity by using the solution 2 is 56.54%. And that's all. Thank you.
Greetings to Dr. Matsa. I'm Vajavan from Image Processing, Section 2, Group 9. I will be explaining about the proposed solution 1 and 2 by our team. The noise images to be restored are filled with salt and pepper noise. Therefore, in both solutions, we use the medium blur filter with kernel size 7 to remove the salt and pepper noise from the images first, and then apply different unsharp image to sharpen the images. Before I proceed with explaining our restoration function in detail, I will explain about the overall structure of our program first. Our program should be run using command prompt and receive two command prompt arguments. The first argument is the file path to read noise image, and the second argument is the file path to write the restored image. We refer to the similarity.py program provided by Dr. and configure the process command line function to read and return two arguments only. Our main function begins with processing the command line arguments and store it to the file variables. After that, read function from CV2 library is called to read the noise image from the file with index 0. After reading the image index 0, the restoration function is called, and we are passing the image 0 and file 1 to the functions. After getting the restored image, the display function is called to display the noise image and the restored image. The process flow of solution 1 is shown in the figure at the left, and our coding is shown at the right side. In our solution 1, which is restoration1.py, after medium blur, we use Laplacian composite filter with coefficient 5 to sharpen the medium blur image to get the image with emphasized edges and details. Then we apply subtraction on the medium blur image and filter image to get the high frequency details. Lastly, we add the high frequency details back to the medium blur image to obtain the restored image. For our solution 2, which is named Restoration 2, after medium blur, we use beam blur with a mask 7x7 to blur the medium blur image again instead of sharpening it. Then we perform similar operation, which is subtraction of the blurred image by the medium blurred image to get the fine details and low frequency components. After that, we add the low frequency details 3 times back to the medium blurred image to increase the image similarity. Additionally, we also applied Laplacian filter with coefficient 4 on the medium blurred image to get the enhanced edges, and then add it back to the resulting image from the previous edition to get the restored image.
I'm Naikaijin and I will present the result of each restore image using the solution 1 and solution 2. And from this table, we can see all the reference image, noise image, and restore image using the solution 1. And for the reference image, we use the image from A6, B6, and C6. And then these are the noise images. And then after we apply the solution 1, these are the restore image that we obtain. And from this image, if we compare to the reference image, we can see that almost all the noises are removed. And based on this pixel similarity result, we can see that most all of the images has the similarity up to 60 and above percentage. Like for image A6, we have the similarity up to 62.95, and then for the image C6, we have the highest, which is almost nearly to the 70%. And for the B6, we have the lowest one, 60.48%. This is because maybe due to the background that has color, while the original image does not have any color. But after we restore, due to the noise image has some color at the background, so this may causes the similarity become lower. And then I will proceed to the result using the solution 2. And from solution 2, we can see that start from the A6, we can see that the pixel similarity become 56.54, maybe due to the restore image become more blur. And then if compared to this reference image, we can see that although there does not have any noises, but we can barely see the edges of the image. Then if we see for the image B2, we can see that the percentage up to 73.13. And if we compare to the reference image, we can see the shape of the gun, and also the background color become more near to white color. And then for this image C6, we can see also the noises are removed and the image become blur, and this lead to this 70.2% similarity. And if we see on this table of comparison, we can see that from solution 1, we have almost every image restore have 60% similarity. And for solution 2, the image B6 and C6 has the percentage up to 70, while the image A6 has only 56.54. And then if we see on the explanation, maybe because on the solution 2, we restore the image and make the image become more blurred and show less detail, while the solution 1 exhibits more detailed features. And then for the B6, image B6, we have the highest similarity, as due to we can see that the background color as more near to the original image. And that's all for the explanation on each result. Thank you.